Hey guys, welcome back. Today is day 58 and today we're going to talk about the curve of best fit. Okay, we're going to use Desmos to determine the curve of best fit. It's going to be very similar to how we did line of best fit. So we're going to start you go to Desmos.com and you choose start graphing. In the upper left you're going to add an item that which is going to be the table. You're going to type the data into the table and input the X and the Y values. Okay, you're going to note with the X and the Y values to see what the column headers are. So we'll do this with an example. So if you look at the first example, David hit a golf ball from the top of a hill. The height of the ball is above the green is given in the table below. So here we have a table. Our input values are X would be the time in seconds, and the output would be how high. So if David's at the top of a hill, so say he's got a hill here, and here's David. Okay, he hits the golf ball. Where's this golf ball? I don't know. He hits it. It's going to go up, and then it's going to come down. Okay, so and it's going to go at in the shape of a parabola. Okay, so he starts out on a hill, and then he hits the ball. Okay, so we're going to use Desmos graphing to plot the points and describe. We're going to think about the characteristics of the data. So how we're going to do that is here's Desmos. Okay, we're going to go up here to the left corner and it says add item. We're going to add a table. Okay, and we're going to notice the column titles are X1 and Y1. That's going to be very important. Okay, we're going to enter our values here. So our input is 1. Or 1 second, so we had 1 second, and then the output is 52.5. Okay, if we had 2 seconds, our height would be 73, okay, 0.2. After 3 seconds, the height was at 74.6, and this is all in meters. After 4 seconds, okay, our height would be at 55.8. And then at 5 seconds, the height would be at 16.1. So it started coming down here. Okay, so if we look at our graph, we're going to zoom out so we can see some of these points here. Okay, we're going to take these points and we want to come up with the curve of best fit. So let me zoom in here. Okay, so we're going up. We hit a high point and then we come down. So the curve of best fit is going to, by using Desmos, you're going to type in, notice you have X1 and Y1. So this is going to be Y1, okay, and then this little tilde, that little squiggly, okay, then AX1, so AX1, and that's going to be squared, okay. So if you want to get squared, you can either pull up the little keyboard, which is in Desmos. There it is. Whoops, got a little bit too big. I'm going to pull up the keyboard. Hold on and get back in the screen so you can see it. So I pulled up that little keyboard. So that way I can type in AX squared, okay, and it's plus BX, again, X1, okay, plus C. Okay, so when we type that in, notice it draws the curve of best fit and it gives you your parameters, your A value, your B, and your C. Okay, so all 3 values, you're going to note those and you're going to round them to the nearest 10th value. Okay, so when we get those, all right, we have our A is negative 10.1, our B is 51.4, and our C is 11. So when we get the curve of best fit, the answer is, okay, is going to be the equation Y equals negative 10.1 X squared, okay, plus 51.4x plus 11. Because remember, in standard form, we've got our AX squared plus BX plus C. Okay, so we're just taking these 3 values and plugging them in. Okay, so that gives us the curve of best fit. All right, we can then use that curve of best fit to make predictions. Okay, so if we take this and we want to see how high the ball would be at 0 seconds, all we have to do is come over here and we can actually just type it in. You can use Desmos to do it, or you can just calculate it. Okay, in this case, it would be our Y is equal to negative 10.1 times 0 squared, okay, plus 51.4 times 0, okay, plus 11. Well, if we calculate that out, we end up with our y is going to be equal to 11. So it's 11 meters. All right. Again, we're using this equation. Our y is equal to negative 10.1 x squared plus 51.4 x plus 11. All right, so we're going to use that now for 2.5 seconds. We're just going to plug in 2.5 for our x. Our y is equal to negative 10.1 times 2.5 squared plus 51.4 times 2.5 plus 11. Okay, so when we multiply that out, we're going to get approximately 76. Okay, 76.4 meters. Okay, so the other thing you could do here is just go to Desmos. Let's try it in Desmos. Okay, I'm going to get rid of these two. And I'm just going to put it in here and say, okay, what is negative? We've got our negative 10.1 times 2.5. And we're going to square that. Okay, plus we've got 51.4 times 2.5. All right, oops, I write 2.5. Yep, there should be a point. Okay, and then that's going to be plus 11. Okay, notice we get 76. Okay, so it's approximately 76.4 meters. So you can use Desmos to just plug it in and treat it like a calculator as well. Okay, so our next example that we have, okay, is, we have the other part, which is when did the ball hit the ground? Okay, for this one, you're just going to want to look at the graph. All right, let's look at the graph. And when we look at the graph here, we can see, oh, we already deleted it. Oh, no. Okay, but if we put the values in again, you're going to see your curve, and you're going to see that it crosses the x-axis right at about 5.3. Okay, so you're going to zoom in and see the x-intercept. Okay, so for purposes of time, I'm just not going to. Well, let me go back and put my table in again. You guys can go ahead in this part of the video, but I accidentally did erase it. So I've got my 1 is 52.5. Okay, my second is 73.2. Okay, my third second is 74.6. Okay, and then the fourth is 55.8. And then after the fifth second, we've got 16.1. Phew, there we go again. All right, put the data in again. Sorry about that. And again, it's good practice. Y1, making sure that's is going to be equal to AX1, and we're going to square that, plus our BX1, okay, plus C. Okay, so notice our curve of best fit. We can now zoom in, and we can see where it crosses. Okay, so it's crossing the x-axis right a little bit more than 5. Okay, so go back in again. All right, right about 5. We're going to say about 5.3. Okay, so it's going to be about 5.3 seconds. All right, the other thing you could have done here for a precise answer is to just put these values, A, B, and C, into the quadratic formula. So this is going to be approximately 5.3 seconds. Okay, the other way to do it would be to identify your A, which is a negative 10.1. Your B is 51.4, and your C is 11. Okay, you could take those values and plug them into the quadratic formula. All right, B squared minus 4AC, all divided by 2A. Okay, and if you did that, you would get two solutions. But in looking at our graph, okay, when we did graph it, notice one of the solutions is actually negative, and negative time does not make any sense. So we're going to throw out that one answer. So sometimes that happens with the word problems. Okay, all right, so moving on, okay, we have another example. All right, a herd of caribou is moved to a small remote island where they have no predators. Data on the population of herd was collected for 6 years. So we're going to use Desmos and determine the curve of best fit. Okay, so I want you to round it to the tenths. So again, you're going to go in, your x1 values and your y1 values, you're going to put them in. Okay, and then you're going to get your equation. All right, so for purposes of time, I'm not going to do that here, but if you practice it, your A should be about 5.8, and your B is going to be about negative 2.9, and your C would be equal to 28.5. You can put that together in an equation. Y is equal to 5.8 x squared minus 2.9x plus 28.5. And if we wanted to predict the population in 10 years, okay, we're going to plug it in. We're going to let our x be equal to 10, and then plug it in. 5.8 times 10 squared minus 2.9 times 10 plus 28.5. All right, and if we do that, we're going to get approximately 580 caribou. Okay, so 500 approximately. All right, and so we can do another one here. All right, you're going to put these values in again. You've got your x1 and y1. Okay, the equation for the curve of best fit, your A is going to be negative 14.4, your B is going to be negative 13.6, and your C is going to be 1,840.8. So you can write the equation of the line as y is equal to negative 14.4 x squared minus 13.6x plus 1840.8. All right, if we want to make a prediction, where's the penny located after falling for 10.5 seconds, we're going to let our x be equal to 10.5. Okay, and we're going to plug it in. And this might be an easier one to actually go back to Desmos. Okay, and we're going to plug it in here. So when we do that, we've got negative 14.4. We're going to multiply by 10.5. We're going to square that, okay, and then it's minus 13.6, and that's times 10.5 again. All right, and then plus 1840.8. Okay, when we do that, we get approximately 110.4, and that's feet. Okay, so 110.4 feet. All right, and when we do that, so our y is equal to negative 14.4 times 10.5 squared, okay, minus 13.6 times 10.5 plus 1840.8. So we put it in the calculator. Our y is equal to 110.4 feet. Okay. All right, so this is a little bit different than a line of best fit that we did earlier in the year. So just as a quick review of the line of best fit, we add this in Desmos the same way, plus table. All right, make sure this is your x1 and this is your y1. So your inputs is the total number of fat, and then you get your total calories output. All right, so you put those values in, and when you put those values in, you're going to see that you're going to get the line of best fit right here. And let's see, when I did that, let's see. Okay, I think there was a little bit of a typo in here. We found out a little bit later. So 2440. Okay, we've got all those values in. Let's see what I did. All right, but your end result should be, when you get your line of best fit, it's actually going to be 11.7. It's a little bit closer here, 11.7, and then this B is going to be 193.9. Okay, so that's going to give you your slope and your y-intercept. So when you write the equation of your line, okay, again, this is 11.7, and this one is 193.9. So this is going to be y is equal to 11.7x plus 193.9. Okay, so that's how you do it. All right, guys, please practice the problems that you have in your homework. Okay, it's really just practicing with Desmos and understanding the two equations. So line of best fit, y1 tilde mx1 plus b, or you could say ax1 plus b. Or curve of best fit, y1 tilde ax1 squared plus b x1 plus c. Okay, so that's the difference between your line is going to be a linear function, quadratic is going to be to the second power. All right, guys, have a great day. Bye.